And I get to use the example of this very building to do that. Probably you know, or maybe you don't, that on Halloween there's an event that takes place in this building, or really from the top of this building, which is called the pumpkin drop. So let's illustrate this idea of rate of change with the pumpkin drop. So what happens is this building, well, let's see, here's the building. And here's the dot. That's the beautiful grass out on this side of the building, okay? And then there's some people up here and very small objects. Well, they're not that small when you're close to them, that get dumped over the side there, and they fall down. That's, you know, everything at MIT, or a lot of things at MIT, are physics experiments. So that's the pumpkin drop. So roughly speaking, actually, the building's about 300 feet high. We're down here on the first usable floor, and so we're going to use, instead of 300 feet, just for convenience purposes, we'll use 80 meters, because that makes the numbers come out simply. Okay, so we have the height, which starts out at 80 meters at time 0, and then the acceleration due to gravity gives you this formula for h. This is the height. So at time t equals 0, we're up at the top. H is 80 meters. So this is the units here are meters. And at time t equals 4, you notice 5 times 4 squared is 80. So I picked these numbers conveniently so that we're down at the bottom. Okay, so this notion of average change here, so the average change, or the average speed here, maybe we'll call it the average speed, since that's over this time that it takes for the pumpkin to drop, is going to be the change in h divided by the change in t, which is, it starts out at, what does it start out as? It starts out as 80, right? And it ends at 0. So actually, we have to do it backwards. We have to take 0 minus 80, because the first value is the final position, and the second value is the initial position. And that's divided by 4 minus 0, time 4 seconds minus time 0 seconds. And so that, of course, is minus 20 meters per second. So the average speed of this guy is 20 meters a second. Now, so why did I pick this example? Because, of course, the average, although interesting, is not really what anybody cares about who actually goes to the event. All we really care about is the instantaneous speed when it hits the pavement. And so that can be calculated at the bottom. So what's the instantaneous speed? That's the derivative. Or maybe I should, to be consistent with the notation I've been using so far, that's d by dt of h. All right? So that's d by dt of h. Now remember, we have formulas for these things. We can differentiate this function now. We did that yesterday. So we're going to take the rate of change, and if you take a look at it, it's just the rate of change of 80 is 0 minus the rate of change for this minus 5t squared. That's minus 10t. All right? So that's using the fact that d by dt of 80 is equal to 0, and d by dt of t squared is equal to 2t. The special case, well, I'm cheating here, but there's a special case that's obvious. I didn't throw it in over here. The case n equals 2 is that second case there, but the case n equals 0 also works, right? Because that's constants, the derivative of a constant is 0, and then the factor n there is 0, and that's consistent. And actually, if you look at the formula above it, you'll see that it's the case n equals -1. So we'll get a larger pattern soon enough with the powers. Okay, anyway, back over here, we have our rate of change, and this is what it is. And at the bottom, at the point of impact, we have t is equal to 4, and so h prime, which is the derivative, is equal to minus 40 meters per second. So twice as fast as the average speed here. And if you need to convert that, that's about 90 miles an hour, which is why the police are there at midnight on Halloween to make sure you're all safe, and also why when you come you have to be prepared to clean up afterwards. So anyway, that's what happens. It's 90 miles an hour. It's actually, the building's a little taller, but there's air resistance, and I'm sure you can do a much more thorough study